Well. Hello everyone and welcome into yet another live stream, and I'm gonna actually need a second because I started this a bit earlier than I should have. Give me a second. Just there we go. Some soda music in the background. Hi the X7. Welcome to the live stream. Okay, that was a bit too quiet. I think. There we go. Seems better. Hi the Alex! Oh, hi. Hi, give me a second. I just need to read a couple of messages. Give me a second. Just a second. Right, I'll be right there. Alright, there we go. Hi there everyone, I'm back. Just one quick message, right? That's all I had to do. Anyhow, the point is, you already know the drill, right? Yes, you do. At least I hope so. Unless you don't, in which case we'll explain. We're researching this. There we go. Material science, still chemistry. Well, it's material science. It's a bit different from chemistry because it's... Well, actually, we haven't really gotten to material science, have we? It's from quantum mechanics to chemistry, actually. It's the underlying principles for now, which means it's more quantum mechanics, actually, than chemistry in the traditional sense. At least in my opinion. Oh, I love to have that. Anyhow, the point is, we are... Where were we, actually, last time? I don't remember. Oh yeah, bonds don't exist. Structure, yes. Structure without molecules, stability and reactivity. This is the one, I think. Am I too quiet? Am I too loud? I have no idea. The point is, this is what we are studying, and this time we're gonna power through because I don't know, last couple of streams we haven't really researched much, so we have to make up for it. We have to make it up, even some might say, considering that, you know, I'm making it a very comical thing to say. The point is, structures without molecule stability and reactivity. The precise definition of bonding energy described in another lesson. There's no important here. But the moment you only need to know that we already been through this, but I don't really remember exactly where I finished. Hi, the TFTA. I finally make it indeed. Oh yeah, I took a picture just for this live stream, and we're gonna research. We're gonna power through. It's gonna be great. Oh, that's methane. Yeah. Heat. Yes. So they only go one way. Many molecules are energy stable enough to meet the criterion. Yes, okay, so we've been over this. How we depict chemical structures. There we go. Oh, that's actually really simple. You could have watched the stream at half speed. Don't, mate. This is... I already... Just unsubscribe from Patreon. I beg you. You're gonna make me... I feel guilty now. Is that what you want? Me feel guilty? You better unsubscribe. I just can't. Oh, I'm gonna... Now I'm gonna be the one who's... Oh, I'm gonna waste 15%. Guilt trip. I have to guilt trip you back. I'm gonna waste 13%. I'm telling you. Okay, the point is, hold on. I'm getting sidetracked again. Ah, it's happening all over again. Every single live stream. Alright, actually, I should actually divide my attention better. Captain Surreal. Hi there. Welcome to the live stream. Chemical species are traditionally represented by structural formulas such as the one absorbed for the as a big one, vitamin C, which we show here. Is this wait, no, it's methane. What? The lines, of course, represent the chemical bonds of the molecule. More importantly, the structural formula of molecule defines connectivity, as was illustrated in the comparison of ethanol and the methyl ether shown above. Okay, so ordinary formula showing conductivity only. Ball and stick model showing the chemical bond and bonding geometry, but individual atoms unrealistically separated. Yes. Hi there, Aurelians, welcome. Space filling model showing relative sizes of the atoms and general shape of the molecule, but not all atoms visible. No obvious chemical bonds here. Yeah, so basically all of the representations are imperfect because it's the quantum world, and you know, my goodness, I hate exams. How are the exams? How, did you do well, or do you still have some left? Was the reason? One limitation of such formulas, they are drawn to dimensional paper screen or small molecules of three-dimensional shape. Okay, makes sense. You will probably be spared having to learn this convention till you get into second year chemistry. I want to learn it now. I miss all the pan live streams. Oh, don't worry, the pan live streams weren't that great. Well, depends on what you consider great, actually. They were social live streams. Oh, damn it, you are right. You've missed social live streams. Now you're joining into the science live stream. That's awful. I'm so sorry, but this time we have to do science. We have to make up. We've been lucky when it comes to science. Real plastic ones or images the reveal much more about molecular structure, bond stick, space filling. Okay, so this is all basics. Finally, we get C1, 2009 beam scientists emerging real molecules, technique known as atomic postmark. Okay, so this is all cool, no? But we kind of have to speed through it, so you know. I'm kind of trying to speed up the pace a bit, because we're a bit behind visualization of molecular structures. Observable properties of bond atom pairs. There we go, finally, somewhat. When we talk about the properties of particular chemical bond, we are really discussing the relationship between two adjacent atoms that are part of the molecule. Diatomic molecules are of course the easiest to study, and the information we derive from them help us interpret the various kinds of experiments we carry out on more complicated molecules. It is important to bear in mind that the exact properties of specific kind of bond will be determined in part by the nature of other bonds in the molecule. Thus, the energy and length of the CH bond will be somewhat dependent on what other atoms are connected to the carbon atom. Makes sense, it's a very complex thing, right? Everything is dependent on everything else. Similarly, the CH bond length can vary by as much as 4% between different molecules. That's an interesting thing to mention, actually. Okay, that's cool. I had no idea it was a thing, but it makes sense. For this reason, the values listed in the tables of bond energy, bond length are usually averages taking over a variety of compounds that contain specific atom pair. In some cases, such as carbon-oxygen or carbon-carbon, the variations can be much greater, approaching 20%, which basically means that this can vary, the length of the bond can vary up to 20%, which is a lot. That's crazy. I had no idea it was a thing. That's really interesting, because we usually think of molecules as, well, just like building blocks, and we don't realize that there is still a lot of complexity happening over there. In these cases, the values fall into groups which we interpret as representative of single and multiple bonds, double and triple. Okay, potential energy curves. There we go. It's actually really funny because I can't tell you all why it's really funny. Because that would require me to reveal something about an upcoming video, but it's really funny why we're right now getting it doesn't matter. The point is, potential energy curves. The energy of a system of two atoms depends on the distance between them. At large distances, the energy is zero, meaning no interaction. At distances of several atomic diameters, attractive force dominate, whereas at very close approaches, the force is repulsive, causing the energy to rise. Okay, so repulsion, attraction, hold on. Yes, so really close same charges push it, basically cause repulsion follows the slope of the energy curve. Yeah, but hold on. Morse curves. Oh damn it! Morse already got the code. Why does why do they also get curves? Some of us don't even have one thing named after them. Why does Morse get code and curves? That's unfair. They are quite useful in defining certain properties of a chemical bond. My brain just froze because I was trying to do 3 different things all at once, and now realized I was gonna switch to music. There we go, fixed. Plus that illustrates those Morse curves, and they are quite useful in defining certain properties of a chemical bond. Okay. Morse curves. So illustrate the relationship between... Wait, is it between repulsion and attraction, actually? It feels more like energy to internuclear distance. Wait, hold on. How should I word this? Between energy and internuclear distance, right? Energy and internuclear distance. Unless I can't even read graphs, in which case... Whoops. Also, this is comical, in my opinion. But the point is, potential energy versus position distance. Yes, okay. Cool. Why am I just stuck on this? Hold on, this is simple stuff. Why am I stuck on this? There's nothing to think about in this scenario. I don't know why I'm thinking about this. My brain is blank. Okay, the internuclear distance, because it's quite super, isn't it? The internuclear distance at which the potential energy minimum occurs defines the bond length. Makes sense. It just wants to, you know, reduce the potential energy as far as possible. That's just what things do, right? That's not even a quantum mechanical thing, that's just a mechanical thing. The potential energy really likes going down. Yeah, potential energy, am I right? Potential energy, ha ha ha. This is more correctly known as the equilibrium bond length, because thermal motion causes the two atoms to vibrate about this distance. In general, the stronger the bond, the smaller will be the bond length. That's useful to remember. In general, stronger the bond, the smaller the bond length. Which once again also makes sense. Because long bonds mean... What would be the relation? Well, the relation here that this would be more to the left in a long bond. As someone with potential energy myself, I can relate. Hi, the Crumbly until the end. Stag, by the way. As a child, I had a theory which states that a concept called time cannot be infinitely divisible, because this would cause the energy entropy to be infinitely divisible. Yeah, but if it's not infinitely divisible, then that means it's discrete, doesn't it? Which causes a lot of problems. It has to be continuous. A paradox of time. The same goes with space, and practically, actually almost everything. Well, I guess not matter. Matter has this cheap trick, doesn't it? Matter has some funky tricks to save it from the discrete versus continuous problem. Attractive forces operate between all atoms, but unless the potential energy minimum is at least of the order of RT, the two atoms will not be able to withstand the disruptive influence of thermal energy long enough to result in an identical molecule. I am not doing well. Why is calling cup full of Tilly? Like, why? Which is what, mate? Mate. Mate. The point is, thus we can say that the chemical bond exists between two atoms in hydrogen. The weak interaction between argon atoms does not allow argon-2 to exist as a molecule, but it does give rise to the van der Waals force that holds argon atoms together in its liquid and solid forms. Hold on. Argon is a noble gas. Yeah, precisely. Wow, look at me. I'm such a smart boy. I remember that argon is a noble gas. Argon is a noble gas, and yet it can bond with itself. That's really interesting. That's really interesting. Potential energy and kinetic... Okay, that's actually really interesting. I had no idea argon could even bond with itself. Noble gases... ARR. I don't know what that means. I'm not a chemist. Or a quantum physicist, for that matter. I get it, because matter. I may not be a quantum physicist or a chemist, but I am quite funny. Remember to like and subscribe. The weak attraction between argon atoms does not allow argon-2, so two argons, to exist as a molecule, but does give rise to the van der Waals force that holds argon atoms together in its liquid and solid forms. That's interesting. Potential energy and kinetic energy, quantum theory. Let's try again. Potential energy and kinetic energy, quantum theory tells us that an electron in an atom possesses kinetic energy K as well as potential energy P. But how am I supposed to remember which is which? So the total energy E is always equal to the sum of the two. E equals P plus K. Yes. Schrodinger's equation, if I do remember correctly, says something rather similar. The relation between them is surprisingly simple. K is... I'm sorry? K is equal to negative half of P. I feel like there is some additional math required to get there. E is equal to P plus K. Hold on. There must be some additional math required to get there, right? Because if you subtract P from both sides... I mean, if E is equal to half of... It doesn't make sense. Bonding orbitals, I'm getting there, slowly but surely. I want to first do the background. Or, I guess, I don't want to skip over any chapters. I'm weird that way. Hold on, what am I missing? K is equal to negative half P, so-called variable theorem, and it's something that is also used in astronomy for systems that have been run very long and became stable in equilibrium. Didn't know it came up here. Hold on, but why half of P? Negative half of P. I'm hyped to learn organic chemistry. So am I. I already picked a textbook even. But I do want to get through this first, because this is the basics, and basics are important. I really wanted to do a organic chemistry live stream today, but then I realized that I should actually, you know, I shouldn't be this childish, and so I will first get the background out of the way. You're making my first person shooter game. When it's finished, will you give it a try? Heck yeah, of course I will. That sounds amazing. When you're finished, send me. We'll do a whole live stream out of it, or this live stream segment, because I really do like the idea of doing main channel streams and they're mostly about science. But heck yeah, I will. Okay, so I'm going to skip over the K is equal to half of P, and I just want to mention just how, Alex, you may not even register that, but I just want to mention just how impressive it is. Like, for you it might be obvious, but the fact that we just come across, you know, a random kinetic energy is equal to negative half of potential energy equation, and you're like, oh yeah, that is called a viral theorem. You know, just, yeah, that thing, which we all know exists and we all knew, right? I just want to say that that's incredibly impressive. But anyhow, this means that the chemical bond forms an exothermic process with the change in energy smaller than 0. Yes, because it's smaller. The change in energy is smaller than 0, because otherwise it would be an unstable bond. That's what you get for staring at stuff like that for a few years. It's not going to waste. I mean, listen. For you, it might be obvious, but for me, that's really cool that you can just, I don't know, we come across a random equality like this, and you're like, oh yeah, viral theorem. You know, I know it from astronomy, because. Did I mention that I'm glad to have you here, Alex? Alright, the point is, the decrease in potential energy is accompanied by an increase in kinetic energy. Makes sense, you can't really destroy energy. I'm pretty certain that's one of the rules of physics, embodied in the momentum of the bonding electrons. But the magnitude of the latter change is only half as much, so the change in potential energy always dominates. The bond energy, negative delta E, has half magnitude of the fall in potential energy. Okay, I get it on the surface, but only on the surface, so let's go through it again. I got that reference moment. I thought make it as an expert in every category in news community. It's so cool. Right, isn't it cool? At this point, I'm actually... Wait, hold on. Wait, I genuinely might have an expert in every category. Oh, wow. Wait, you're right. I do have an expert in every field of science. Well, every main field of science. I do. That's mostly because of, well, okay. We don't really specialize yet. We don't have that enough people to actually specialize, but when it goes to general fields of science, you know, only the big boys, general ones, then I really do. So we have a mystery person, which I can't reveal right now, because I've actually only got in touch with them 2 days ago for math, so I can't reveal who that is yet. I'm just a huge fan of them, that's all I can say. Then we have Alex for physics. We started with quantum mechanics, but just physics at this point. Astrophysics, classical mechanics, quantum mechanics, doesn't matter. Scrap for chemistry. You, Ali, for medicine. Okay, when it comes to my abstraction-based division of science, that's really everything from math to medicine, which are the only ones I actually care about. Everything is covered. That's wow, that took me by surprise. Isn't that cool though? Finally, we got to the point where I don't have to know anything in order to make videos about things, because I just have the experts to do all of the work for me without getting paid a single dime. I mean, anyhow, just speaking of changing the subject. Nice question. Yeah, we really got them all. Hold on, this. Okay, so for now, let's just trust. You know what? I trust Alex with my life. K is equal to negative 0.5p. Okay, this is just true. Let's just accept it as a fact, because, you know, there we go. This is a fact. So now, assuming that is true, let's go through this yet again. This means that when a chemical bond forms an exothermic process with delta energy smaller than 0, because the energy is going down, once again, stable bond, if the decrease in potential energy is accompanied by an increase in kinetic energy. That's why the bond is stable, because the potential energy is going down, it's increasing kinetic energy, so increasing the temperature, and because of that, it actually requires more energy in order to reverse that process, hence stable. Embodied in the momentum of the bonding electrons. So the increasing kinetic, so this means the increasing kinetic energy embodied in the momentum of the bonding I'm not a linguist, this is actually really difficult. Like the chemistry, you know, well, quantum mechanics, that's not the toughest bit. The toughest bit is the linguistic aspect. But the magnitude of the latter change, So the change in kinetic energy is only half as much because of this equation, right? That's what this equation tells us, is only half as much as potential. So the change in potential energy always dominates. So the change will be in potential energy will be twice as large than change in kinetic energy. The bond energy, negative delta E, has half the magnitude of the fall in potential energy. So if energy is equal to P plus K, then delta E, I think this is based on feeling, so it might be off. Wouldn't this be true? And if K is equal to this, then I'm pretty decently certain, once again, this is based on a feeling, this is based on a hunch, so I might be way off. This should also be probably true, which means this? Which means minus, which means this, which means the bond energy has half the magnitude of the fall in potential energy. Kind of? I have no idea what I'm doing. Oh, this is completely right. Now we're doing math like a physicist. So, this is completely based on my feelings, and we all know that best science is done completely based on the feels basis. No, but this does make sense, right? If energy is equal to potential plus kinetic, then difference in energy has to be equal to difference in potential and difference kinetic. Yes, that's... yeah. I don't want to prove this because the simplest things, what's wrong with me today? I can't speak. The simplest things are always the most difficult to prove, so I'm not gonna prove it. Instead, I'm just going to assume that I'm correct, and we're gonna move on. Feelings don't care about your facts. I would like philosophy. I wonder if continuous time and space can be described as convergent series. For example, the space is continuous but has a certain length. I don't think space being continuous goes against it having certain. I think you can have if you have a function, for example, you can have a finite, like a finite portion of a function be continuous. I don't think that's exclusive. Like if we go to desmos.com and if we do, never remember. What's the notation like? X squared. It was square brackets. There we go. Ah, I'm so intelligent. I remembered the notation, which makes me intelligent by definition. That's actually, if you check in Britannica, that's the definition of intelligence. Ability to remember Desmos notation. We don't do Marvel physics. For physics, we simply don't know what happens below the Planck length. That is true, but I don't... wait. But Planck length is like... that is true, but... I may be wrong. Obviously, I may be wrong. This is a child checkup. I may be wrong. Should be like plastered on top of the screen. But I'm pretty certain Planck length is the limit of a model, isn't it? So basically, we don't have a model to accurately describe anything that happens below the Planck length. But just because we don't have a model, we don't have to assume that is the smallest length. That's just the smallest. That we just have a skill issue collectively, all of humanity. It's always past 12 AM for me. Most of the time, it's also past 12 AM for me. Actually, my streams are all over the place. Right now, it's around 8 PM. It's the length scale where theories break down, yes. I love it. Honestly, I really love it how I can just say random things and then Alex can like reword them to make me sound smart. I really like that. You know what? I really like that bit. But our experiments are conducted far above that limit, and so down there theory is all we have. Yeah, but also, what's the point? What this is doing with the Planck length? What are you doing? Come on now, mate. How has your sleep schedule been, make it? It was fine for a couple of weeks. well, but I mean, I don't get physics. Why would physics go down to Planck? Come on, mate. So small. You can't even see them. You can't even see those. What do you mean? You're just experimenting with atoms now. You can't even see those. How are you supposed to know if you're correct? What are we doing? Oh yeah, right. This is my incredibly scientific and professional proof, which I like to call semi-math or pseudo-math, which the bond energy negative delta E. Wait, hold on. This actually might be correct. If we multiply both sides by -1, the bond energy negative delta E has half the magnitude of the fall. That's why it's negative. Half the magnitude of the fall in potential energy. Yes. Cool. So it's all just simple math. Show us the spreadsheet. Wait, I actually haven't seen the spreadsheet recently. I mean, I have been filling it in. I just don't have a graph for it. I was just mindlessly filling it in without actually... Hold on. Chart week 17. I'm only now making the graph. It could be worse. It could be worse. Could be worse. I don't want to go into when I also the colors are all screwed up because I'm using dark mode and yellow is green all of a sudden. Oh no, that's getting ready. Yellow is that's so ugly. Ew. Oof. 35% is great actually, isn't it? See, I sleep a lot. That's good. That's good. It's objectively great. We don't have to go into when I sleep, alright? That's not important. The point is, bond energies. That's what's important. I'm certain that God gives a universe full of plot twists to, I guess, born in the end because there is no end. Wouldn't the minus cancel out from both sides? No, because we multiplied both sides by -1. If we multiply it by -1 again, we'd get this. So we multiply both sides, we do it like this. Basically, that's what we do. Okay, so this is just basic math. I'm glad to hear that this is just basic math, because that's kind of all the math I know. As long as you're getting sleep. Precisely! You don't have to stop worrying about me. Gee whiz. Mum. Bond energies is the amount of work that must be done to... Hold on. Oh, the work really, for some reason... again. The bond energy is the amount of work that must be done to pull two atoms completely apart. In other words, it is the same as depth of the well in the potential energy curve shown above. Okay, so the deeper the well, the stronger the bond. Because you need more energy to pull them apart. Let's see if I'm correct. Always remember when you're studying something to ask yourself these questions ahead of time, because if you only ask those questions after you've actually researched the thing, then that leads to all sorts of biases and stuff. Of these nasty things. Survivorship bias and whatnot. This is almost not quite the same as both decisions actually refer to break the chemical bond. The difference is that very small 0 point. Wait, the difference is the very small 0 point energy. The relationship will be clarified below in the section on bond vibrational frequencies. Why? What's up with waves? What's the deal with waves in quantum? Am I right? I need... Bro need answers, not sleep. You know what? I'm even gonna forgive the usage of bro in that sentence, because that's just it. Oh boy, molecular vibrations. Here we go. Oh no, Alex, that's not reassuring at all. I really like how you study and take notes. I mean, my notes are a complete mess. Look at this. Election standing model. The elections can move to places where they can't move. These are my notes. So, I mean... I guess you're correct. I do take notes. New Apple input joke just dropped. What's up with waves, am I right? Yeah, what's up with waves and quantum, alright? What's the deal with waves? Messy notes, big brain. Don't try to... It's just... Come on. I never bought that. The whole messy things means a genius person thing, like... Waves don't matter. Yeah, I very much beg to differ. I very much beg to differ after dealing with 7 different values to describe a single thing. Oh wow, wait. No, it's 6. Never mind, it's just 6 different values to describe wavelength. You have a period, you have a wavelength, you have a wave number, you have the angular frequency, you have... oh, what's the inverse of a period? I don't remember what the inverse of a period was. And all of those things describe just the wavelength. Well, they can't be... Well, they don't just describe... You know what? I'm tired. We're not doing this time. We're not doing this. Y'all just go and watch quantum mechanics video in case you don't get what I'm talking about. No, just go and watch that video. The segment with the wave function where there are like... there is the angular frequency, which is I think the time version, the wave number, which I think is the position version, and then you have the period, which is like the wavelength for time, and then you have the wavelength, which is like the wavelength, which is like the period for position. You have the last bit, which I don't even remember. It was crazy. Oh no, wait, it doesn't matter. The point is, use of bond energy to estimating of heats of reactions. Let's stay on track, okay? Make it. Quit distracting me. Gee, I can't with this guy. One can often get a very good idea of how much heat will be absorbed or given off in a reaction by simply finding the difference in total bond energies contained in the reactions and products. The strength of an individual bond, such as oxygen and hydrogen between them, the bond between them, depends to some extent on its environment in a molecule. That is, in this example, what other atoms is connected to the oxygen atom. Guessing hydrogen will be used for this example. But tables of average energies of the various common bond types are widely available and can provide useful estimates of the energy of heat absorbed or released in many chemical reactions. What's the 428 kilojoules per mole doing though? Ethane. Okay, so this is... Hold on, just to get a clear picture. Ethane. Ethane? But... Hold on, what... But... Which part of ethane? Wait, we're dividing it by 2? Hold on. Ethane? Do you like typing notes rather than writing? Depends. It really does depend. I have a notebook which I use for my videos, but I use Google Docs for... I use Docs for live streams because, you know, it's easy to showcase on stream. I use a notebook for my videos, but for me it doesn't really matter. Personally, I retain subject and write it. For me, it doesn't matter. I mean, I feel like generally writing stuff down is a good idea because then you like force yourself to ingest the message. You can't write something down without first reading it. And so when you write something down, you're just forcing your mind to actually ingest the message and not just gloss over it. So yeah, writing it down is certainly a good idea. Badly organized notes show that you don't read them. They're not badly organized, they're badly written. There's a difference. I was here 3 days ago and early bit morning. I swear to God, I saw the same formula. Yeah, I mean, yeah. We're kind of circling around the same bit the whole time. We're kind of doing the same thing, but from different perspectives. Wait, I don't get this though. Ethane. Absorbed on recent chemical reactions. Ethane. What reaction? Is this my CSS not working, or depends what I'm studying? Like, homework, I type, but notes I write. Yeah, that's fair. Oh, you should see the notes for. You know what? Hold on, let me show you. Which I got for my videos recently, and notes are just beautiful. Well, not really beautiful. They're actually. Well, I use notes. Listen, I note stuff down in a very different way than most people would. Okay, when you're learning stuff for school or for homework, whatever. If you're learning because, and you're learning in a, if you're, damn it. Okay, give me a second. I feel like I'm having a stroke. Okay, if you're learning things in an official way, so basically, I like to call it learning for someone else, right? So for an exam or anything like that, then yes, having orderly, clear notes makes sense. But when you study things for yourself, it's different. And that's why you can then actually note things down out of context, with no context. Just, you know, things, our little BTS of video creation. Yeah, should I actually make it public, pun intended? Should I make it public or should I, you know what, should I make it public or are we doing Patreon only? Waiting. There we go. I'm going to show the picture on stream, but patrons will get an additional bit of information that I won't show now. There we go. Patrons got a little additional bit of information there, but I will show the image on screen. And I guess if... Sorry about that. If you've been paying a lot of attention, then you probably... Well, okay, first of all, the image will be upside down because I'm just special. But this is what my notes usually look like. This isn't just an example. It's upside down. Hold on. Actually, let me just rotate the image because there's one bit which is comical. Options. Wait, how do you rotate things? How do you rotate? Wait, I'm not good with technology. Okay, it's difficult stuff. You have like so many programs. Image crop. No, don't crop it. Rotate the thing. BGM, is that background music? It's made by Soda Casey on YouTube. No, we don't have any bots on this live stream. We only have humans. That's what my mods are for. Mods, what are y'all doing? Just not helping. The people ask for the song. I like how I don't reuse mod roles for what they were created for. created for... What's wrong with me? Damn it! Make it... Oh, gee. I feel like I'm having a stroke. Deep breaths. Oh. Sorry. No, it's fine. I'm trying to rotate an image and I'm struggling hard. How do you rotate things? Hold on, I need Photoshop for this because I can't just... I don't have Photoshop. You don't have to, it's fine. It's in the description. For everyone, I'd just like to mention that. That's what I get for having an open window. You rotate using that one formula. I don't... What? No, I meant just how do you rotate in Windows? Because I just copied the picture and I thought it would be easier, but I forgot how special Windows is. And yeah, I know I'm getting sidetracked again, just trying to rotate an image. Wish it was easier, am I right? It's fine, I'm fine. There we go. Damn, that was surprisingly difficult, actually. I could have done Python. There we go. Okay, I rotate the image. This is... Oh, people who quantum mechanics think it's difficult have clearly never tried to rotate an image in Windows. There we go. Control R in Windows Photo Viewer. Oh, I really wish I knew that. I don't know how Windows works. I'm not used to the fact that you have so many shortcuts, okay? Who needs that many shortcuts? Control Shift Windows Alt L in case you want to open LinkedIn, which is a real shortcut, by the way. But yeah, this is what my notes usually look like. If someone can tell me what this is, I'm gonna give you... If someone can guess what this is, I will give you a... I wanted to say mod for a second, but no. The LinkedIn users appreciate that shortcut. That's a powerful shortcut. Is that really? No. This is just... This right here is me trying to desperately save something which was unsavable. I just need to Google it real quick to get that. There we go. Get the name right in case someone actually guessed it. Any guesses what this is? You have only you have 8 pins and only 3 of them are labeled. Hi there, Savad Third. Welcome, Lashim. Alright, I feel like that's enough getting sidetracked, right? Also, Life is Pain circuit. Lovely. It really is a Life is Pain circuit. But anyhow, back to the molecules, I suppose. One can often get a very good idea how much... Oh yeah, ethane. I don't know what ethane is doing there. We'll just assume that we understand, and then we'll just assume that we're correct. Bond lengths and angles. Breaking of hydrogen bonds and then forming ethane bonds. I've shown the difference of -202 kilojoules per mole. So breaking of hydrogen bonds and then forming the ethane bonds. So this is the reaction of forming ethane. That's what ethane means, right? That's the bit that confuses me. Yeah, okay, glad to know. That's the bit that confused me. It just says ethane and not like any specific, just ethane. That's it. Just a quick brain break helps learning. Backyard rugby program. Wait, we don't have a single poll in. Wait, what are we polling today? It's like that one Veritasium video about nitrogen points. I haven't seen all that many Veritasium videos. I am a Vsauce. I'm a Vsauce guy myself. I know you don't have to pick. Vsauce grade and Veritasium. I don't know, they're different. Their kind of content is different. Veritasium uploads a lot more videos than Vsauce. Vsauce uploads once or twice a year. Used to upload a lot more. It's like that one Black Mirror episode with AI. Wait, there is no way there was only one Black Mirror episode with AI. I haven't seen Black Mirror, but I'm assuming they had... There's no way there was only one episode. Bruh, it's like saying pizza is better than chocolate. Yeah, precisely. Yeah. That's actually a very good analogy. Alright. One can often get a very good idea of how much heat will be absorbed. Oh wait, no, we've already been over this. Bond lengths and angles. The length of a chemical bond, the distance between the centers of the two bond atoms, the internuclear distance. Bond lengths have traditionally been expressed in angstrom units, but picometers are now preferred. Makes sense because it's metric. Bond lengths are typically in the range of 1 to 2 angstroms or 100 to 200 picometers. That's 1,000 of a nanometer. Even though the bond is via a nanometer is 1,000 of a micrometer. Even the bond is a micrometer is 1,000 of a millimeter. Even though the bond is in a millimeter is 1,000 of a meter. Even though the bond is vibrating, a meter is just a standard length unit. Even though the bond is vibrating, equilibrium bond lengths can be determined experimentally within 1 picometer. That's incredible. Wow, that is incredible actually. And really impressive. Okay. Here's a question. If you could only pick one, more money, more free time, or more fame? More fame. that's an easy question. More fame gives me okay, more fame gives me more money and more free time. Well, actually, not more free time. No, I would end up with less free time, but I don't actually want free time, do I? That's an easy one. How much more fame can you handle? Mate, as if fame is difficult. Everyone, oh, we can do that as a poll. Well, no, it's a very specific kind of poll. I don't think that's a relatable poll. I know how many YouTubers do we have in watching the stream. You know what, we're gonna... I have a different question. I think I have a different question for Paul. Kim Kardashian stream. We don't know. Maybe you're watching him even. Huh? Ever thought of that? No, I don't have any ideas for Paul. Anyhow. Wait, actually I have a question for you all. It's just a general question, okay? General loose question, you know, just hypothetically, alright? Asking, hypothetically. Is it legal, okay, and hold on, hear me out, okay? Is it legal to share information, just theoretical, hypothetical information, on how to make substances which it is illegal to make without the... No, hear me out, okay? Is it legal to share information about creating substances which it is illegal to make by yourself? By the way, hear me out, okay? Would it be illegal to share the information on how to do the thing? Like a scientific, from a scientific point of view, not like... Depends. Yeah, that's what I'm trying to figure out, because obviously it has to be illegal in some cases, but maybe it could be legal in others. YouTube won't be proud. Let me get a list of ingredients on how to make meth. What? You're not far. That is very illegal. Yeah, but there's no way it's a binary illegal, right? There has to be a spectrum. Because it disrupts public order. As an AI language model. That's a great one. Yeah, but there has to be a spectrum, right? Like, obviously, cooking meth on stream, that's obviously illegal. But like, talking about the structure of meth, that's not illegal. That's illegal. That's on Wikipedia. I don't know how to spell meth. I don't really care for meth. There we go. See, this is meth. You can see the structure online if you want for free. So it's certainly not illegal to share some information. So now, where's the limit? That's what I'm curious about. I think it would be legal if it's for education. Yeah, but how do I convince YouTube that it's for education? Isn't there like a book called... It's not Anarchy Handbook, it's Anarchist Cookbook. Come on. And every self-respecting internet user has one. I mean, well, no, I don't, because it will be determined in court. Well, you see, that's the bit. I don't want it to go that far. Just put a disclaimer saying it's for education, and YouTube is usually good with that. I guess. Okay, Prussian blue. To be fair and free and balanced, Prussian blue is getting away with a lot of things on YouTube. Like, I mean, a lot of things on YouTube, okay? A lot of things on YouTube, okay? So, like, yeah. I guess it's a bit... It's flexible, right? You don't need to convince us. We'll have to convince YouTube what I know. Education, precisely. I'm just curious where the boundaries are. Hypothetically, alright? Just a thought experiment, out of curiosity. I am a huge fan of the idea of, learning where the line is by crossing it, but it's just, I'd rather not get demonetized. I like money. Some might even say I love money. Or just be like, hey, YouTube, this is a hypothetical joke. Yeah, you see, this entire video, that was just like, from a theoretical point of view. Anyway, guys, don't forget to like and subscribe, everyone. Just say in Minecraft. What will happen? Oh, can you? That would be such a great bit, though, if I made like a whole video explaining how to make something, and then just ended off in this Minecraft mod or something. Oh, that'd be great. Yeah, I mean, that's the thing, right, Ramit? That's precisely what I'm saying. When it comes to meth, for example, whilst I'm decently certain that's a big no-no to share actual instructions on how to make meth, the structure of meth itself is is widely available, right? You can check it on Wikipedia. And then the methods for creating different, in organic chemistry, all of these different structures have different names, but I haven't gotten to organic chemistry yet, so I don't know them. The point is, the methods for creating them are also widely available. It's just a matter of connecting the dots. And honestly, if I was just to show these two things separate without connecting the dots, that would make for a very unsatisfying video. That's my main problem. I saw people on Twitch getting away with live threads via in GTA roleplay, of course. I don't know. I don't feel comfortable playing the in Minecraft card, honestly. Anyhow, bond lengths depend mainly on sizes of an atom, and secondarily on the bond strength. The stronger the bond, tending to be shorter. Bonds involving hydrogen can be quite short. The shortest bond of all, hydrogen, is only 74 picometers. That is short. Wait, hold on. On size of the atom, bond strength. So stronger bond tending to be shorter. So bond between two hydrogen atoms is strong. Oh, I am. Oof. Would this? What does carbon poisoning smell like? Oxide poisoning? My brain feels funny. The shortest bond of hydrogen is only 74 picometers. Multiple bonded atoms are closer together than singly bonded ones. This, basically. As you can see, the more bonds between carbon, the shorter the bond length. Makes sense. This is a major criterion for experimentally determining the multiplicity of a bond. This trend is clearly evident in the above plot, which depicts the sequence of carbon, single, double, and triple bonds. Hold on, let me just drop it in here, because I like this graphic a lot. I'm stealing the graphic. Make its height has to be measured in picometers. No, but there is something else that has to be measured in picometers, and that's not fun. The most common method of measuring bond lengths in solids is by analysis of the diffraction of scattering of X-rays when they pass through the regularly spaced atoms in a crystal. For gaseous molecules, neutron or electron diffraction can also be used. Okay, so this graph is the most important bit. It shows us how the bond energy... The mole is unnecessary there, in my personal opinion. Like, the mole is such a given, I don't... So, we have the bond length. This is basically the corner of strong bonds, right? The further in this direction, the stronger the bond, if I'm understanding this correctly. Because this is the bond, and wait, bond energy is the difference in energy, right? Amount of work that must be done to pull two atoms completely apart. Yes. So the further you go into this corner, the more bonded they are. Remember double slit? That's what crystals do to X-rays. So by observing the pattern, you can also find the bond length. That makes sense, actually. Huh. Who would have thought that physics makes sense? In my language, your first name means religious. Wait, who's... In my language, pico means the female's main part. I feel like you're lost in the source. Don't... What's going on in chat? What are y'all up to? Y'all are up to some shenanigans, you know? This is a serious live stream. We're talking about serious stuff. Bond stretching and infrared absorption. Okay. Oh, this is the same graphic. The energy to nucleus distance. Okay. In Minecraft. In Minecraft. Okay. When an atom is displaced from its equilibrium position in the molecule, it is subject to a restoring force which increases with the displacement. A spring follows the same law. Wait, hold on. I just realized I was rendering something in the background. I should actually resume the render. Hold on, give me a second. You know, never mind. Just go back to chatting about whatever you were chatting about. Bread thumbs up. That's a solid conversation starter. Definitely has nothing to do with the animation I'm making, but what does petrol look like? Just out of curiosity. I'm just, you know, just a random thought. Chemical formula. Dude, that's... Oh, mate. Oh, mate. Benzene! This is benzene! Yeah, right. So, for example, you know, hold on. So, like, you have methamphetamine. So, you know, like, for example, when it goes to benzene, you can get a formula for benzene, and it's responsible for, it's, you know, and it's this bit. For example, right? As an example. So, for example, you can easily find bits about... Also, when it goes to the CH bits, I'm certain that... xylene seems like a better fit, actually. And so, or maybe... It's like, you know, you can get these bits if you want. And then from it you also have the end dot, which is the meth itself, and then it's only a matter of connecting them. So, is the process of connecting the dots illegal? That's my question. Isn't benzene group like super toxic? It's not, it's different, doesn't matter. The point is, petrol... I mean... I have no idea. Asking me, I don't know, I'm not a chemist, especially not an organic one. Petrochemical formula. Hold on, what does the petrochemical formula actually look like? Petrol. What is petrol? Petrol. Petroleum? Is that it? Oh, is petroleum different than petrol? Is this whole YouTube thing just a front? No. What game? Why would you think that? That's weird. What a weird... Alex, you're so wacky, you know? What a wild theory. Wait, why is it so difficult to find out what petrol is like? Was it is this petrol? I can't tell. So I'm sitting in my car studying, it's raining, my neighbors are having a mowlawn competition in the rain. Oh, we've got some hardcore neighbors. Petroleum, petroleum. Okay, so petroleum and petrol is the same thing, right? What is the difference between petrol and petroleum? What's the difference between? Is there a difference? Or petroleum versus petrol? When to use each one? Oh no, these are different things. You probably want petroleum, but in the script it's petrol, and that part of the script wasn't rewritten by me, so I don't know. It was written by a chemist, and that chemist knows a lot more than me, so I might be off. Wait, is 51 read divisible by 17? Oh, it is! Oh, that's the weirdest division I've ever heard of. I don't really know either. Yeah, this is... Wait, hold on. It's 6 plus 45. Yeah, it really is. Wow, that's wild. This has nothing to do with anything we've been knowing about. It's just a wild fact that 51 is divisible by 17. The point is... Petrol. Petrol is gasoline. Okay, so petrol is gasoline. When in doubt, Wikipedia, because it at least like is consistent. Petrol. Petroleum. Fudge! Who is this? Why is it German? Just standard, good old wiki. Yes. Gasoline. So it is gasoline. Gasoline in a glass jar. Thank you for the helpful thank you for the helpful image. Chemistry. Physical properties, chemical analysis and production, yes. There we go. Wow. Components of gasoline. I'm looking for the whole thing. I'm looking for it combined. Petrol versus petroleum. First section, third paragraph has the answer. First section, third. Petroleum is a broad term, refers to all types of crude oil and natural gas. Petrol, on the other hand, is a more specific term that refined product used for fuel. Okay, so this is petrol. Petrol. So gasoline. Okay. Now all we need is like this, except combined already. This is just the components. Some of the components, not even all of them. Oh, also glucose, another thing which I'm curious about. Glucose. What's glucose? Okay, glucose is simple, which means we're probably looking for, well, okay, simple is a relative term, obviously. Relatively simple. So we're looking for something similar to this. That's not helpful. This without oxygen. Don't ask me why I'm giving you all of these clues. This is just... Fun fact, you can make glucose out of any kind of wood. Doesn't wood already contain? I don't know. It's sugar, right? You can, fun fact, you can make glucose out of these. I don't remember what they're called. Some atoms or something. I don't know. It's too complex. I'm not a chemist. Okay, I think this is what we're looking for. H3 with carbon. Not really. That's the end. Well, no, because it has carbon connected to carbon connected to carbon connected. One carbon connected to 4 carbons. Right here we have carbon connected to 2 carbons at best. Facts. That's not what we're looking for then. This looks like what we're looking for. I need... In chemistry you can make anything out of anything. In chemistry you can make anything out of anything if you try hard enough. You know what? No, I'm just gonna ask. Hold on, this is just what now? Okay, there we go. It's so nice actually knowing people who are like experts when it comes to chemistry and all this stuff. It's a nice feeling when you ask an expert a question and you can just completely trust an answer. It's something you don't really get all that often, you know? Make it has got like a chemist friend on speed dial. I don't have him on speed dial, but I do have him as a friend. At least I consider them a friend. Well, I'm more... No, it's more like I'm a fan of them, I'd say. But it is nice. It's something you don't really get all that often, because when it comes to main sources, they are really often confusing, and when it comes to things which are supposed to simplify the main sources, in these current times it's AI chatbots, for, you know, most of the time, then you can't really trust them, can you? You can't really trust AI chatbots. They still hallucinate. So it's really nice when you ask an expert and you get a simplified version which you can trust. It's a really nice feeling. The point is, bond stretching and infrared absorption. When an atom is displaced from its equilibrium position in the molecule, it is subject to a restoring force which increases with displacement. So the more displaced it gets, restoring force... I might be wrong, but I'm guessing it restores. A spring follows the same law. Yeah, so it's like a spring, okay. A chemical bond is therefore formally similar to a spring that has weights, atoms, attached to its two ends. A mechanical system of this kind possesses a natural vibrational frequency which depends on the masses of the weights and the stiffness of the spring. These vibrations are initiated by the thermal energy of the surroundings. Chemically bonded atoms are never at rest at temperatures above absolute zero. Yeah, that's what temperature is, right? Okay, initiated by thermal energy, so they basically vibrate? Natural vibrational frequency depends on the masses of the weight and the stiffness of the spring. So each atom, each molecule has its own natural vibrational frequency, right? Oh wait, it's a mechanical system of this kind, so it's not only molecules, it's also ionic stuff then. I think. 78% certain. Okay. On the atomic scale, in which all motions are quantized, a vibrating system can possess a series of vibrational frequencies or states. These are depicted by the horizontal lines in the potential energy curve shown here, so these ones, right? Notice that the very bottom of the curve, which would violate... Wait, the very bottom of the curve does not correspond to an allowed state, because at this point the positions of the atom are precisely specified, which would violate the uncertainty principle. This, right? Right here, if we were to add a line, it would be specified. Is that what? I have no idea what I'm doing. Oh, hi there, space enthusiast, welcome! A series of vibrational frequencies. So, vibrational quantum number is that? Ground vibrational state of molecules, that's 0. I think I get what... I think I get it. But at the same time, I don't think I get it. Like, I get it, but I think I'm wrong. The lowest allowed or ground vibrational state is the one denoted by 0, and it is normally the only state that is significantly populated in most molecules at room temperature. In order to jump to a higher state, the molecule must absorb a photon whose energy is equal to the distance between the two states. Okay, so this is very rare because it has to absorb an exact kind of photon. I'm sorry, space enthusiasts. We're just all so enchanted by all of this. For ordinary chemical bonds, the energy differences between these natural vibrational frequencies correspond to those of infrared light. Each wavelength of infrared light that excites the various motion particle bond will be absorbed by the molecule. In general, the stronger the bond and the lighter the atom it connects, the higher will be its natural string frequency and shorter the wavelength of the light absorbed by it. Studies on a wide variety of molecules have made it possible to determine the wavelengths absorbed by each kind of bond. By plotting the degree of absorption as a function of wavelength, one obtains the infrared spectrum of the molecule, which allows one to see what kind of bonds are present. Okay. What I'm getting from this is that... Hi Yas! Oh, it's been a while since I've seen you around here. Okay, what I'm getting from this is, unless I'm wrong, which I probably am, molecules vibrate only at discrete energy level? In your whole life, what's the question you still have in your mind? Like the question I have? The most important... I don't know if I have one. I don't know if I have a question like that. Hold on, give me a second. Let me think. Do I have a question like that? I don't think I have like a single question. It is important. They have certain possible patterns of vibration. Okay, but does that say that? I mean, there's certainly some discreteness to it, right? Discrete, as in non-continuous. So does that say that it can only vibrate at discrete frequencies? In different patterns have different energies. Okay, so you can energize a particle, a molecule. You can energize a molecule for it to vibrate at different vibrational quantum number frequencies. Yes. Yes, I'm assuming yes to the first one. Okay, so as discreteness. Now the second question. Okay, so that's simple enough. Alrighty then, which means... Wait, but what does energizing a molecule this way do? Oh, it moves it up! Oh, I get it now! And so if you energize it too much, you can break up the bond. It's getting late, see you on another stream. See ya, random space enthusiast. Wait. Is that a way to dissolve a bond? If you energize it with correct photons. That's cool. That's really cool. Oh, it's a nice animation. Hold on. What did you send? There we go. Molecular vibrations. I mean, yeah, I get how vibrations work. No, I've missed you. You quantum mechanical energy. You. I mean, it's just energy, I guess. But it doesn't. But it don't need no mass. That's what makes it quantum mechanical. In my heart. Okay, so if I'm understanding this correctly, you can basically dissolve, in quotes obviously, dissolve a bond by energizing a molecule with correct photons, which is cool. That's sick. Infrared absorption and global warming. The aspect of bond stretching and bending frequencies that bugs our lives most directly is the way in some of the gases in the atmosphere absorb infrared light, and that's the effect of the heat balance. Yeah, okay. Owing to their symmetrical shapes, the principal atmospheric components, and so nitrogen and oxygen, do not absorb infrared light, but the minor components water vapor and carbon dioxide are strong absorbers. Oh, that makes sense. That makes so much sense. Especially in long wavelength region of the infrared. So any source of the infrared ray will tend to warm the atmosphere, so as the greenhouse effect. That makes so much sense. So basically, if we, as humanity, pump crazy lot of carbon dioxide into the atmosphere, then the infrared radiation would get absorbed by the bonds, making them weaker, but at the same time it would make them weaker because the bonds would vibrate more, because they would have more energy. And what kind of energy? Thermal energy, which means that we would get a sort of warming of the globe. Wow, I guess we really shouldn't pump any carbon dioxide into the atmosphere, because that could be really bad. Oh, and is that why methane disappears quicker than carbon? And is that why methane is like more active than carbon? Because it absorbs even more, and because of that it basically heats up the atmosphere quicker, but at the same time it dissolves quicker, because you can't really turn that into thermal energy without also dissolving the bond. This makes so much sense. Oh my goodness. Yeah, we'll probably be bad with global warming. Oh my goodness, I just had my House MD realization click moments. The guy swallowed a toothpick or something. Wait, the last part might need some. You mean the methane part? Is that really not correct? Because that makes sense. Wait, really? Is that not that? Wait, hold on. Methane greenhouse effect. It was not crime, but the principle is correct. Hold on, I need to know. I need to know. Was that really not? But I was going off so hard. Come on. Methane. Wait, hold on. What are we looking for? We're looking for this. So Morse curve of methane. Can I get a whole molecule? Morse potential. I don't care. Is there no Morse curve for methane? Just a general. I'm looking for methane's Morse curve. Just prove me right. Just prove me right. Pressure redemption. No, I don't care. That's not important. That's not what I'm looking for. Methane absorption spectrum. Just finish your abstraction series you composed. Man, I can tell you some kind of ambiguities I've had before. I never would have thought human behavior falls into the abstraction, but now that you mention that even geography and politics fall into the mix, it's crafted so well and simplified. I'm really glad you like it, because abstraction is a very important thing, in my opinion. That's why I have so many videos about it. Thank you so much. I'm really glad it helped, and I'm really glad you liked it. Yes, your electronic video is awesome and has helped explain and clear up some electrical topics that was taught to me during this semester. Well, then you're gonna like the next video on the channel. Or actually, no, the next one's gonna be about chemistry. But soon, in a couple of weeks, I'm gonna release another electricity video, which will explain it even better, because I'm not really all that proud of the electric versus electronic video. I really think I could have done better. And right try, but the last part sounded a little wrong about methane lasting longer than carbon. No, I meant it lasts shorter than carbon. That's not lasting longer because it absorbs more infrared. That's what I said. Less because it absorbs more, so it heats up quicker, but at the same time the bonds, you know, weaken. Absorption spectrum of methane. Okay, so when it comes to methane, absorption coefficient, wavelength. Okay, so we have wavelength. Absorption coefficient is higher than. Wait, this seems like what I said. I'm misinterpreting this, which might be the case. Wouldn't be the first time. You can say that's true. Well, I can say that anything is true. We don't care if I can say it's true. We care if it is actually true. That's what we care about. Okay, absorption coefficient per centimeter Why is this a length? Wait, why is this a length? Why not anything else like surface or volume? Why is this length? Wait, why is this length? Hold on. Okay, this. Why is this length? Why is this in relation to length? I am so confused. It's per centimeter travel through main gas. I see. That's why length. That makes sense. Okay, so high absorption coefficient means that it's getting up. Yeah, I mean, doesn't this? So far, it's all aligned with what I've said, right? Am I? Hold on for a second. ResearchGate. Let's go to the source instead of just looking at the random graph. Yes, I am a human. Oh, I didn't even need to solve captcha. Reject everything. It's Polish article. Okay, so we only have the graph because I don't want to go that much in depth. I don't care enough about what I said to go that much in depth. So methane absorbs more than carbon dioxide, yeah. Well, I said. And then because it absorbs more, it gets more energized, so it releases more thermal energy, but at the same time the bonds break quicker, and that's why it. There we go. This. Dropping the atmosphere, gases interact with infrared light. That's because the energy from damage some molecule carbon dioxide methane infrared on its way out. So what happens in infrared energy? Why do you know? It's really below the molecule structure, molecules on an atom. Methane, for instance, traps around 120 times as much heat as CO2 does moment to moment. Okay, so far everything is on track. Good. I like it when things are aligned with what I say. So far we're on the right track. Vibrational potential multi. Been down that some molecules named that. Molecules don't care like to yeah, we know the theory. Methane is essential carbon atom by. Methane has got many more dance moves. I love that analogy. So many more vibrational rotation modes. Yes! I'm right! I was right! Oh, wow. I'm feeling my house MD mode. Oh, this is phenomenal. Oh, even strong gases. Some human-made gases like chlorofluorocarbons and sulfur hexafluoride are yet more geometrically complex and may trap thousands of times as much heat as CO2. Oh, I'm so glad. The reason methane lasts shorter is because the carbon-hydrogen bond on the weakest side. Carbon dioxide, however, is like a very strong bond. Yeah, but we don't have to care about, you know, all the other stuff. We can cherry pick the data to make me seem like I'm smart, you know? Hi there everyone, welcome to another episode of Ethical Science with Make It. How to cherry pick data. Listen, I feel like we're getting distracted. The point is, I was right and I'm cool, and that's it. That's all that matters. Oh, that's actually the end of the subchapter. It's taking ages for me to get through a single hour and a half to get through like 3/4 of a subchapter. Electron tunneling model, but I don't want to. In conclusion, it is stronger because there are more bonds which can vibrate in different ways, but it lasts shorter because the bonds are weaker than CO2 and break more easily. Yeah. If you take away the because bonds are weaker than CO2, because I had no idea it was a thing, then that's precisely what I've said, and I'm coining it. I'm coining a fact. I was so right. You're totally right on the absorption phase, 100 times more heat trapping in CO2. Precisely. Let's just focus on that part and disregard the additional bits. We don't care about the additional bits because I didn't mention them, so we don't care about them. We only care about the things that, you know, I said and were true. We don't care about the things I didn't mention and are also true, okay? We're cherry picking. Oh no, we're actually going over... Oh no, we'll go over all the quantum models. Quantum mechanical models. EP. Okay, this actually doesn't seem all that bad. We can just go back to these. So yeah, it's not as bad as it could be. I feel, you know what? Let's go. You know what? No, we won't end the stream just now. We'll get. I'm having something is wrong with me. I don't know what. Something is wrong. Give me a second. You missed an entire chapter? What do you mean I missed an entire chapter? When? When did I miss an entire chapter? We just did this one. Now moving to the next one. No chapters missed. Everything on track. Don't scare me like that. It's very important to me. I actually go over every single chapter. Don't gaslight me. Oh, I need a second. I need a second before going into the quantum mechanics yet again. It's fine. It's fine. You have Alex in charge. It's okay. Okay. Let's go for it. About models in science. I know all about models, trust me. Okay, in our phase you need to find scientific explanation, explanation of model, example of model. Yeah. One thing is clear. Chemical bonding is basically electrical in nature. There's a result of attraction between bodies of opposite charge. The bonding occurs when outer shell electrons asymmetrically are attracted to positively charged. Yes, we know what this already. Not all pairs of electrons can form stable bonds. Different elements can form different numbers of bonds. So, valence, yes. Geometric arrangement of the bonds around a given kind of atom is a property of the element. We've been over these. We don't care about the history. Time to get to the models. Hi, December. Welcome to the live stream. Let's get into the models then, everyone. It's going to be fun. Time to have fun. Okay. Classical bond model. We're starting the ionic model, that's interesting. Alright. The ionic model, which... Ever since the discovery, I don't care about the history. Electrolytic solutions contain ions having opposite electrical charges. Opposite charges attract, so perhaps the substances from which these ions come consist of positive and negatively charged atoms held together by electrostatic attraction. I want to know something. Is this stuff present in high school textbooks of USA? I don't know. Ali? I don't think you had that in high school, did you? I mean, okay, no, classical models might have been there, but I don't think quantum models were. No, there's no way quantum models were in high schools. There's a question about the high school textbooks in the US of, can I get an amen for our troops? A. High schools specialized? Do people specialize in high schools? No, high schools are general, right? I have no idea. I have these quantum models in my high school. I know we had models in college. College is higher than high school, right? I mean, I don't know. Well, then that's the answer, I suppose. Okay, electrical solutions contain ions having opposite electrical charges. Opposite charges attract, so perhaps the substances from which these ions come consist of positive and negatively charged atoms held together by electrostatic attraction. Makes sense. It turns out that this is not true generally. Never mind, doesn't make sense. I take that statement back, I was just joshing around. But the model built on this assumption does a fairly good job of explaining a rather small but important class of compounds that are called ionic solids. Never mind, I take back taking it back, I was actually right all along. I was talking about models. The most well-known example of such a compound is sodium chloride. Everyone's favorite when it comes to ionic examples, which consists of two interpenetrating lattices of sodium with missing electron and chlorine with additional electron. Ions arranged in such a way that every ion of one type is surrounded in three-dimensional space by 6 ions of opposite charge. Yeah. The ionic solid is more stable than the equivalent number of gases atoms simply because the three-dimensional NaCl structure allows more electrons to be closer to more nuclei. This creates the stability of any kind of molecule. All that's special about the ionic bond is that we can employ a conceptually simple electrostatic model to predict the bond strength. That's nice. Okay, so ionic is the simplest. Got it. The main limitation of this model is that it applies really well to a small class of solids composed of group 1 and group 2 elements with highly electronegative elements are halogens, although compounds such as copper with chloride to chlorine change into ions when they dissolve in water. The fundamental units making up the solids are more like polymeric chains, commonly bound copper and chlorine to molecules that have little ionic character. Cool. Actually, might not do any notes for this one. Shared electron covalent. This model originated with the theory developed by Lewis. Don't care about history. We know what covalent means. We know this. Usually each atom contributes 1 electron, one valence electrons the pair, but in some cases both electrons come from one of the atoms. For example, the bond between hydrogen and chlorine in the hydrogen chloride molecule is made up of a single 1s electron of hydrogen paired up with 1 of chlorine's 7 valence 3p electrons. The stability afforded by this sharing is thought to derive from the noble gas configuration helium for hydrogen, argon for chlorine that surround the bound atoms. The electrostatic binding force of the model can be best answered by examining the simplest possible molecule, hydrogen molecule ion, which consists of 2 nuclei and 1 electron. I'm sorry for not contributing to chat right now, by the way, not chatting with you all. I'm not good with high school topics. I don't really have anything constructive to add to the conversation, so I'm just gonna move back the background, you know, just read about some models. Only 2 protons will each other since there's such a molecule exists. Something more than 2 nuclei might to occur. Location with respect to nuclei. If this electron space between 2 nuclei, the bonding diagram, it will attract both protons. Yeah. So this is just like a recap, right? No, I'm not having my house MD moment anymore. I only had that for methane. Can you show us your desktop? I just want to see. I don't really keep my games on my desktop. I keep them in my Steam, in Epic. Don't really keep them on my desktop. You won't try to hack me with your game, will you now? That would be mean. I don't want to open it up in a sandbox, I don't know, I might. I've had people try that before, actually. I have a very messy desktop. So do I, yeah. I mean, I have two desktops. The working one, which is completely clean, and the messy one. He's just trying to hide the furry sex troll cat. No, I'm not trying to hide it. I'm very proud of it. I still have furry sex downloaded on my PC. Alright, got hold of. Have a nice stream, everyone. Bye, Alex. I'm gonna end the stream soon. You know what? If Alex is going, what's the point? What's the point of doing quantum stuff without Alex? Can only be guaranteed in electrical negatives of two atoms are identical. When atoms having a different negative join, the electron share between them will be displaced towards the more electron negative atom, preferring polarity. Yeah, cool. Stop being a coward and stream 36. I'm gonna get demonetized in as it's NSFW. It's very much not safe for work. There is a lot. Okay. There is a lot going on in that game. That's what losers say. Guys, I don't want to lose my 50 cents a day. Did you spend money on that game? No, a friend bought it for me. It was so silly. They're like, no, come on, Alice. Someone just gifted me the game. It was crazy, okay? Like, that was the weirdest. Like, I opened up Steam and then I saw it as a gift. And you know me, it's rude to say no to a gift, right? So I just had to click accept. It was wild, crazy, insane. It is, yeah. See, that's the reason why I have it. Actually, I had to accept. I was forced to accept. Let's talk about your penetration parts. That's a good meme. I like that meme. Can Ray, someone sent me 13 different furry gays and I had to accept them all. Some of them are real fire though. Did you ever do a Lethal Company stream? Yes, I did. 301st live stream was Lethal Company. I remember that. I streamed it on Twitch, so it's not really... You can't really watch the stream anymore because Twitch deletes the streams after a while, but you can watch a recap. Was it fun? It was really fun. Let me show you actually. You know what? That's it. You know, we've done enough quantum mechanics, I think. Let me show you the stream. It's this one. Oh wow! Oh no! Oh! No! It's this one. That's the stream. That's the one. I think I was busy that day. Yeah, I'm present. Also, I've made 2 videos about this live stream. Also, Don't Ring the Bell, which is also a great one.
Oh, it's very safe here.
Nice. Good. It doesn't feel safe.
And editing gaming is so much fun.
So,
The exact same.
what's that noise?
Don't worry about it. I'm set. Okay! I have the $25 stream gift card and I'm deciding what to get. Hold on. Oh, I gotta pick... I'm biased. I am really biased when it comes to picking these. Oh, that was actually the next... Wait, was it the next day? I think that was the next day. What do you mean day 302? That's 301. Huh. Bizarre. Make it. Don't get me anything. Quit that. I am extremely biased, Ali, because I can only pick games for streams. And I guess there are some recommendations. I'm tired. Oh, I still have a video. Oh. You should buy Make It himself. No, honey. 25 bucks. Is that really what you... Oh, is that really think... Is that really what you think I'm worth? 25 bucks. It's not 1800s. Wow. Now they send me a direction to take that joke. Should I buy Make It? How much do you cost to make it? Depends how much you got. Like, I'm not gay. 20 bucks is 20 bucks, right? 23 plus taxes. Hold on, Make It. What time you wake up? Depends. Depends on the day. 25 bucks. Well, I could give you my left hand for this price, I think. I think that's a fair deal. I'm not using it anyway. What's the point of having a left hand? I already got the right one. What do I need two for? You like swimming? I kinda enjoy it. It's fun. Also, the electric tower climb. I think I'd make my... Oh, this is one of those games, isn't it? Why can't I have your right hand? Because it's important to me. It's my right hand. You are white. What do you mean? What do you mean, Damek? What? I don't get that one. Make It. How much for your soul? I don't have it anymore. It's too late, mate. You're too late. For what you sell it for. I already got monetized on YouTube. I don't have a soul. Because the right hand's gonna copy. Precisely! See, Ramit gets it. Y'all, honestly, y'all are really the... Oof. Hour of Progress. I lost Hour of Progress as a rage game. What recommendations do I have for a game? Why did my voice crack on that sentence? That's a bizarre sentence to voice crack on. Oh, well, for 25 bucks, that's a lot. That's a lot of money. That is a lot of money. Let me check. Let me check in my library. What do I have? What do I have? Oh, what should I play with Ali? And what's worth 25 bucks? I don't have that many games actually. Now I'm thinking about this. You know, I'll just run and gacha game and move on regretting. Well, no, I don't have it. Stick fight the game. Stick fight the game. That's what I would spend on, and that's like $2. Stick fight the game is phenomenal because I'm good at that game, and I like it. You're a little mid. Actually, you know what? No, you're mid little, I would say. But still, the point is, it's not a mid game. It's a great game. I'm gonna play it right now. You know what? Screw it. I'm gonna download the game. I'm gonna play it. Oh, don't you ever. Don't disrespect Stick Fight the game. There we go. I downloaded the game already. We're playing the game. That's enough of that music. Come on, go on. I'm gonna play a quick Stick Fight the game to prove Ali wrong. That's the only reason. I just downloaded just to prove Ali wrong. Good game recommendation. Go on. Oh, it's gonna be something. If you're gonna be joshing around, I won't forgive. By yourself, I didn't need all this. Well, you can select a quick match. I don't. Apart from you guys, I don't really have friends. A bit of Minecraft, the create mode has physics and cool stuff. I don't really enjoy the realistic mods in Minecraft. I do enjoy crafting modes. Yeah, the first round is always screwed up, so we just have to wait. I prefer modpack. I prefer FTB stuff, honestly, myself. Stone block 2. Delish. Stone block 3 is a bit weird. Practically all of Sky Factory is great. There we go. All right. Time to show these kids what true love looks like. There we go. Sweet dreams. With gaming is so hard. Dying is gay. Oh, well, I mean, that's not really that much of a discouragement for me. I love throwing guns. I love throwing guns more than shooting them. No, they got me, damn it. I think I was what? Hold on. You're gonna screw yourself over more than me! That's what you get! Oh, damn it. Literally shot himself in the foot. Okay, this is awkward because we don't really want to fight till we get a gun so we can kill blue. Yellow, I swear, you suck. You suck so much. You suck so much. Headshot! Leg shot. There we go! We gaming so hard. See, Ali, do you still think it's mid? I just can't. Okay, well, that's... No, I fell first. Unfortunate. There we go. One eliminated. Now it's time for the second one. Yes, a fellow gun thrower. Oh, I respect those players so much. I am one of them. There we go. Die. Die. There we go. Die. That's how you're supposed to use guns in every single video game. There we go. A bit mid. Ali, listen. Don't take it personally, but you've got no taste. Oh yeah, this weapon just disappears if they hit you because it's a bit laggy. Okay, that was a little pog. It's all pog. Oh, I love this map though. This map is phenomenal because you can just like... Well, you killed yourself. Congratulations. Oh, maybe not. Wait. Alright. League of Legends play. Who? Make fucking skilled 9-year-olds. Heck yeah. Them's gonna... Why do I still have a crown? Oh, blue is still alive. Okay, I get it now. Yo, laser of death. Laser of death. Laser of death! Ah, mate, I tried to push him into laser. Don't send me, please. I don't even need a gun to win this. Whoa! Don't shoot the messenger. Okay, well, I not enough health. This is fun. Ali, do you really still think it's me? You got no taste, woman. I couldn't jump on. I still wanna try Don't Starve with you. Oh yeah, I have Don't Starve, I forgot. Well, I have it, like... Oh, damn it. I really didn't want to shoot him. I always remember, kids, when you get the gun, just... pack it like this. Nah. No firing challenge. I'll still give... no, something jumps out at me. That's actually fair. Look at Minecraft create mode later. We can do it right now. Even I'd say. Like this. Minecraft create mode. Yeah, I know this one. It's just, as I mentioned, I don't really like the realistic physics ones. When it comes to automation, I prefer the good old-fashioned translocators and auto-sieves and auto-hammers with RF as energy. Did you play it before? I think I did. Once or twice. Yeah, I just prefer energy. You know, the good old-fashioned kind where you can just set up a generator and then power up absolutely everything. What's your PC specs? RTX something. Give me a second, let me check. It was AMD, a CPU AMD Ryzen 9 5900X and NVIDIA GeForce RTX 3060. How long have we been streaming for? I feel like it's about time that we end the live stream, you know? 2 hours, yeah. That's about time. So, I'm gonna go for now. That was a fun live stream, but, you know, all good things have to end eventually. On the Streets of Rogue 2 come out. Oh, yeah. Oh, I forgot that's it. Oh, I can't wait. Streets of Rogue 2 does look fun. Anyhow, for now, I suppose that'll be it. That was a fun live stream. We actually did a lot. Did a lot. Got through some. So, for now, that'll be it. Thank you, man, so much for watching, and have a great day.